Hello students, today we will see next topic is design concepts. Here the software designs usually involves problem solving and planning a software solutions. Every software process is characterized by some basic concepts along with certain practices or some methods. Methods represent the manner through which the concepts are applied. As the new technology replaces some older technology, many changes occurs in the methods that are used to apply the concepts for the development of the softwares. Here the set of fundamental software designs concepts has evolved over the history of software engineering. Although the degree of interest in this concept has varied over the years and each has stood at the test of time. The beginning of the wisdom of software engineer is to recognize the difference between getting a program to work and getting it right. The design concept provides the software designer with a foundation from which more sophisticated methods can be applied. The fundamental concepts underlying the software design process remains the same, and some of the which are described here. First is abstraction. Abstractions refers to a powerful design tools which allows software designers to consider components as an abstract level while neglecting the implementation's details of the components. But here IEEE defines the abstractions, a view of problems that extract the essential information relevant to a particular purpose, and it also ignores the remainder of the informations. This is called as the abstractions. The concept of abstractions can provide and can be used in two ways: as a process and as an entity. As a process, it refers to a mechanism of hiding irrelevant details and representing only the essential features of an atom, so that one can focus on the important things at a time. And as an entity, it refers to a model or view of an atom. Three widely used abstractions mechanism in software designing are first is functional or procedural abstractions, then data abstraction, and third is control abstraction. Here these are the types of abstraction. First one is procedural abstraction. Procedural abstractions is a name of sequence of instructions that has a specific and limited functions. For example, a word open for a door. Then here it also having some enter implies a long sequence of the procedural steps. For example, walk to the door, then reach out, turn knob, pull door, etc. Then second is data abstractions, is a name collection of data that describes data objects. An example of data abstractions would be play check. This data object is actually a collection of many different pieces of information such as gross pay amount, tax withheld, etc. And also which having other examples like drawing. Here it also having the data abstractions for a door would be set of attributes that describe the door. For example, door type, swing direction, weight, dimension, etc. Then third is control abstraction. It implies a program control mechanisms without specifying internal details. For example, the synchronization semaphore used to coordinate activities in an operating system. Then second is architectures. The complete structure of the software, which is composed of various components of the system. Then the attributes of those components and the relationship among them is called the software architectures. Then this software architecture is the structure of program modules where they interact with each other in a specialized way and enables software engineers to analyze the software design efficiently. Then here the software architectures allows to overall structures of the software and the way in which that structures provide conceptual integrity for a system. It is the simplest form of architectures, is the structure or organization of the program's components like modules, the manner in which these components interact, and the structure of data that are used by the component. The software architectures enable the software engineering to analyze the software design efficiently. Then the overall structures of the software and the way in which structures provides conceptual integrity for the systems and consist of components, connector and relationship between them, and some of the architectures models are described below. First is here structures models, architectures as an organized collection of the component. Then framework model attempt to identify a repeatable architectures pattern. Then dynamic models indicate how program structure changes as a function of external events. Then process model, it focus on the design of the business or technical process that system must accommodate, and functional models used to represent system functional hierarchy. Then third is pattern. A pattern provides a description of the solution to a recurring design problem of some specific domain in such a way that the solution can be used again and again. The objective of each pattern is to provide an insight to a designer who can determine the following. First, in whether the pattern can be reused, then whether the pattern is applicable to the current project, and third one is whether the pattern can be used to develop a similar but functionality or structurally different design pattern. Design patterns also describe the design structures that solves a particular design problem within a specific context or forces that may have an impact on the manner in which the pattern is applied and used. Software engineering can also use the design pattern during the entire software design process. Here, a pattern is named like the insight which conveys the essence of proven solutions to the recurring problem within a certain context. Competing some concerns, then it having some types of the design patterns. First one is architectural patterns, then design patterns, and third one is idioms. Then first is architecture's patterns. These patterns are high-level strategies that refer to the overall structures and organization of a system. That is, they define the elements of the software system, such as a subsystem, component, classes, etc. In addition, they also indicate the relationship between elements along with the rules and guidelines. For specifying this relationship, note that architecture's patterns are often considered equivalent to the software architectures. Then second type is design pattern. These patterns are medium level strategies that are used to solve design problem, and they provide a means for the refinement of the elements as defined by the architecture's pattern of the software system or the like a relationship among them. Specific design elements such as a relationship among components or mechanism that affect components to components interactions are addressed by design patterns. Note that design patterns are often considered equivalent to the software component. And third one is idioms. These patterns are low level patterns which are programming language specific, and they describe the implementations of software component and the methods used for interaction among software component, etc. in a specific programming language. Note that idioms are often termed as a coding pattern. These are the three types of design patterns. Then fourth is a separation of concerns. Separation of concerns is a design concept for separating a computer program into a distinct section such that each section addresses a separate concern. Then a concern is a set of information that affect the code of computer program. Then the overall goal of the separation of concerns is to establish a well organized system whereas each part fulfills a meaningful and attitudes role while maximizing its ability to adapt to changes. Then, separation of the concern is a design concept that suggests that any complex problem can be more easily handled if it is subdivided into the pieces that can be solved, optimized independently. Concern is a features or behavior that is specified as the part of requirement model for the software. By separating concern into smaller and therefore more manageable piece, a problem task less effort and time to solve. It also follows the perceived complexity of the two problems when they are combined in often greater than the sum of perceived complexity when each is taken separately. Then the separations of the concern is manifested in other related design concepts such as modularity, aspect, functional independence and refinement. Then fifth is modularity. The modularity is the concept in computer software engineering has been espoused by almost 5 decades in software architectures also embodies modularity, and that is software is divided into the separately named and the addressable components often called as the modules and that are integrated to specify the problem's requirements. The modularity is the degree to which a system component may be separated and recombined, often the benefits of the flexibility and variety in the use. In software design, modularity refers to a logical partitioning of the software design that allows the complex software to be manageable for the purpose of implementations and also maintenance. Here, the modularity is achieved by dividing the software into uniquely named and addresses component, which are also known as the modules. A complex system or the large program it is partitioned into the set of discrete modules in such a way that each module can be developed independent of other modules, and after developing the modules they are integrated together to meet the software requirement. So this is the figure curves shown in figure provides useful guidelines when the modularity is considered. We should modularize, but care should taken to stay in the vicinity of M. In this diagram, here M these characteristics lead to the cost or efforts curves shown in this figure. There is a number and M of modules that would result in minimum development cost, and but we do not have the necessary sophistication to predict M with assurance. The under modularity over modularity should be avoided, but how do we know the vicinity of M and how modular should we take software? The size of module will be detected by the functional and applications. So this is the here this curves is software total software cost, then cost to integrate, then this is the region of minimum cost, and here cost module, then number of modules and cost of efforts. But the modularity enhance the design clarity, which is turns eases the implementations, debugging, testing, documenting and maintaining of the software product.